a break. Not refreshed, but I guess I'm glutton for punishment. Alright, what do we have here? Yeah, so my streak is now 0. I guess I have to still solve that one problem to buy a streak extender, or streak recover, whatever. Minimum equals sum of two arrays after replacing zeros. You're given two arrays nums 1 and nums 2 containing positive integers. Let's say n1 is the length of nums 1 and n2 is the length of nums 2. You have to replace all of the zeros in both arrays with strictly positive integers such as the sum of the elements of both arrays becomes equal. Interesting. We can replace all the zeros in both arrays with strictly positive integers such that the sum of the elements of both arrays becomes equal. Return the minimum sum can obtain or negative 1 is not possible. So you have to place the 0 here, or no, you have to replace all the zeros. So you have to place all these zeros here, such that the sums are the same, and the zeros have to be replaced with strictly increasing values, like this one might be 1 and this one might be 2. So 3 plus 2 is 2 plus 2 plus 1 is 6, plus 1 is 7, plus 2 is 8. Plus 1 is 7, plus 2 is 9. Then if you replace this with 1, it's going to be 12. So you have to replace this with something bigger than 1 and 2, but eventually get 12. So like 1 and 2 and 4. Okay. This one's not possible. Alright. Seems kind of simple enough. So let's handle the not possible case. And then I'll handle this possible case. So it's not possible if the smaller one has no way of catching up to the bigger one. So let's go ahead and just do like let's say n1 count, n1 sum is equal to the sum of nums 1, n2 sum is equal to the sum of nums 2, and let's say n1 zeros is equal to 0. This is all kind of bad. n1 n2 is equal to length of nums 1 and length of nums 2. n1 sum and n2 sum is equal to sum of num1, sum of num2. You know what? This is, I should just go sum 1, sum 2. And call this like length 1 and length 2. Let's keep it consistent. And call this 0, 1, and 0 is 2. Oh. 0 is 1 and 0 is 2 is equal to 0. So for every value in nums 1, if the value is 0, then I could do something tricky here. I can increment zeros, but there's probably a calculation that you can perform. There's probably a calculation that you can perform here that just calculates it to increment. So you want 0 to be 1, and then anything else to become 0. 0 to become 1, anything else to become 0. Zero to become 1. Anything else to become 0. can't do divide by 0. Can't do divide by 0. So what can we do? The remainder works. Can multiply by some number. Can you make it equal to 0? Can you do an XOR? 0 XOR 0, 0, the value, and 0, 0 and 0. I think there should be somewhere. For every value minus 2, the value equals 0, then 0s and here's 2 is unconnected. Okay, and then what's the impossible one? So if someone logic would be a lot simpler if I knew which one was smaller. Okay, if someone is smaller than sum 2, and the number of zeros for someone is equal to 0, then it's going to be possible. And so sum 2 is less than sum 1, and the number of zeros in sum 2 is equal to 0. Why is this returning 1? No. Let's see if the detection of the impossible case works. It does not. So it's this one's smaller, and there's no way of catching it. Currently nums 1, sum 1 should be smaller than sum 2. So, oh, it's the other way around. So the zeros allow you to make stuff bigger. The zeros allow you. Oh, okay. Yeah, so this is actually this detection I think is actually correct. It's just the test case doesn't cover what I'm thinking of putting. So if you have zeros, but you are but the smaller one doesn't have any zeros. So let's say this one is just 5. Then there's no way of catching it. Okay. Okay. So now it's maybe I shouldn't care about the sums at all. Maybe I should just care about the difference between the sums. Maybe I should care about just the difference in the sums. Okay, this is too much dabbling for something that should be much easier than the last one. So you should always try to work with try the simplest replacement possible for all your zeros. See what your new sum is, and your other one should match, I guess. Like the bigger the two should compensate. Okay, So let's say sum1 plus equals the so here, if you have some number of zeros, the number of zeros implies a minimum addition of smallest possible positive integers added to that side. For example, if nums1 has 3 zeros, it means unless at min adds 1, 2, 3, min addition is equal to z times z plus 1 over 2. Where z is count of zeros and that side. So if there was 4 zeros, it'd be 1, 2, 3, 4 is the minimum addition, and then it'd be 4 times 5 divided by 2, which is 10, is the sum of those. So sum1 plus equals 0 is 1, 0 is 1, plus 1 times 0 is divided by 0 is 1, divided by 2. Sum2 plus equals 0 is 2 plus 1 times 0 is 2 divided by 2. And then you take the bigger of the two. So why didn't this one work? So the minimum here is now 2 plus 2 plus 1 plus 2, which is 3. 4 plus 3, which is 7. So this one's new minimum is 7. Ooh, and this one's still is 5. So maybe someone this should be done without before. This should be done before this calculation here, because the sums needs to at least incorporate the minimums involved, and it's only after you do that comparison can you say that the zeros can work. So yeah. So if the sum after adding in the minimum values that you need to replace the zeros with is smaller, and there's no way of catching up on the other side. Okay. And then return the minimum. Here there is a way of catching up, so it actually returns the maximum of the sum wants it to. So let's see what this is. Okay, so here, 1 off. Interesting, 1 off. Huh. So 7, 28, 17, 18, this is 35, this is another 35, so it adds up to 70. This is 30, another 30, so it's 60. And then 26, 32, 33, 35, 36. 60 plus 36 is 96. And then if you place this with a 1, this with a 2, that should be 99. Yep. I have to replace all the zeros in both arrays with strictly positive such that the sum of the elements of both arrays becomes equal. I'm somehow calculating this wrong. for the set boosting. Let's go ahead and verify my addition here. Print out the sum 1 and sum 2. So the first sum is 70, the second is 96. Both zeros, so strictly positive integers. Oh, strictly positive integers. So it could all be ones, I guess. Whoopsie. Okay. So the minimum is adding ones for all the zeros. Well, that makes it a lot simpler. I thought I was confusing strictly positive with strictly increasing, I think. 0 is 1, 0 is 2. I don't know how I got my other test cases right if this is screwed up. Alright. Oh. I think maybe the print is probably slowing it down. I can't imagine this being that slow. I don't think I need to actually know the length. Someone handling not possible, but actually later. Do need to calculate the sums. Do need to calculate the number of zeros. I wonder if this is redundant calculation, if I can do them in the same for loop. Let's just try it here. See if the issue is the print. Kind of, maybe. So the number of zeros is 0. You know what? Maybe actually it's easier to do counter. So counts 1 is equal to counter of times 1. Counts 2 is equal to counter times 2. And just not like this. But use the zeros. So counts 1 as 0. Actually, I don't know. If it doesn't actually have it, then does it just crash? This is going to crash here. Let's say zeros is 0, 0, 0, 2 is just zeros. It doesn't have it, then does it crash? All these test cases have zeros. Well, that's not true. This one doesn't have zeros. Yeah, maybe it doesn't actually need it. It doesn't need the if statement to check the first of 0. Counts 1 is 0, 0. Counts 2 is 0, 0. Do. Know if it's any faster. Okay, so yeah, this is another data structure that's probably going to be slow. I think that's the issue. So can I do this quickly? For every value in nums1, if the value is 0, infinite. I think maybe for every value in nums1. Now to do a mapping. So a 0 becomes 1, and anything not 0 becomes anything not 0 becomes I wonder. Can I do something that is zeros? Let's go. Zeros 1 plus equals the value equals 0. Does that evaluate to 1? Okay, let me go ahead and I'll just edit this thing. The value equals 0. Here's 2. This equals value equals 0. Does that work? Oh, I need to get rid of the caps. Okay. Cool. Okay. So that does work. Huh. Okay. No, when that Python does this, this doesn't include at all. I mean, okay. What if you calculate the sum within the loop as well? Sum 1 plus equals value. Sum 2 plus equals 1. Is that any faster? No. No. What is going on here? There it goes. Sum 1 is, yeah, this statement has to be correct, right? Sum of the first one is smaller than the smallest second one. There's no way of catching it. What the heck? How is this possible to make this faster? How is it possible to make this faster? This is darn fast. This is like O of n for sure. O of n plus m, or n or the sum of the lengths of the numbers 1 and 2. Or n is this length of m1, m is length of 2. This is pretty darn. But this is pretty darn slow. Unless there's like a lot of test cases. Well, I guess there's 636. That means your test case takes like a millisecond. Is there something I'm missing here? I take the sum of nums 1 and the sum of nums 2. What was the one that actually was fast? They're all the same speed. 800 something times. Someone did it in like 5 milliseconds? What the fuck? I guess you don't really need to know how many zeros. You just add 1 to the sum here. If you have 0, then sum 1 plus equals 1 else sum 1 equals plus equals the value, and then maybe you just have two variables for has 0. Has 0 1, has 0 2, that'd be false, and make these true. The value equals 0, sum 2 plus equals 1, has 0 2. This seems slower actually. So you don't need this anymore. And so sum 1 is less than sum 2, and there's not has 0 1, not has 0 2. There's no way this is any faster. There's no way. Like negligibly faster. Alright, I'm almost curious to see what the hell the other solutions are. What? Wow, this is verbose. Okay, that's the exact same thing as me, really. With more replace the 0 with a positive 1. Okay, so they're doing a replace. Okay, what is the fastest doing? Lambda open display runtime text. For every value in nums1, the sum increases, the number of zeros increases. For every value in nums2, the sum increases 0. If there's no zeros in both, if there's a 0, they structure their logic around the number of zeros. I don't know what this is doing. Import AI text edit. Display runtime text. I don't know what that is. Well, this seems exactly like what I did. The sum increments. Sum increments. I wonder, is there another calculation I can do? 0 becomes 1, and then 1, anything that's not 1 becomes 0. 0 becomes 1. So you can do the number, 1 minus the number. You can do the number mod 1. So can you do something where the remainder is always going to be 1? So if you have have the number, multiply it by 2, add, you have the number, you have any number that's not 0, you add 1 to it. So it's going to be either 1 or something bigger than 1. And then you take the remainder of it by 2. No. You have the number, you double it. So it's going to be either 0 or even. Add 1. So it's either going to be 0 or even. And then divided by you have a number, so you can make it even number or 0. And then if you did something where you have divided by 2 is just going to reverse the operation. You add 1 to it, 0 becomes 1, 2 becomes 3. You times it by 2, that guarantees even. Then you times it by 3, that guarantees an odd. So if you multiply times it by 6, you times it by an even. Times it by 2, you guarantee an even. Times it by 3, you guarantee an odd. Except if you have 0. No, I got that wrong. So an odd number times 6 is going to be odd. An even number times 6 is going to be even. Then why did I think about an even times an odd is odd? 4 times 3 is 12. No, an even times an even is even. An even times an odd is even. What the fuck am I thinking? Even times odd is even. So if you multiply the number by 2, you guarantee it's being even. And then you take the mod of that number by 3, you guarantee it's going to be, no, you don't guarantee anything. If you add 1, add 1, someone is equal to if the value is 0, increase the sum by 1. I guess this probably isn't great. Increase the sum by the value. I mean, you can do something where like the value is equal to 1, then just increase the sum by the value. That does absolutely nothing. I think maybe you can reverse the order of these, because the check for has no 0 is probably more sufficient for causing it to skip the evaluation. So here, going back, this is sum2, sum1 plus equals 1. Still so slow. Yeah. I wonder if I can ask ChatGPT to come up with a calculation. Calculation causes 0 to be 1 and non-zero to be 0. Any non-zero number raised to the power of 0 is 1. What is this giving me? Oops, something went wrong. Fuck, man. Not available for the search. If we do it to the 0 power, what is 0 to the 0 power? Is it not defined? Okay. So alright, well, it is what it is. I guess I'm going to be satisfied with 68%. Alright. Oh, I should probably do a summary here. This is just simply, calculate the sum of each array. Assume zeros are substituted with smallest possible positive integers. Compare, determine if it is not possible. So smallest sum
array with smaller sum after 0 substituted, zeros subbed out. Has no zeros to replace what, so that its sum cannot increase to match bigger sum, in which case you just obviously return -1. Otherwise it should always be possible to increase the smaller sum to the larger sum by increasing the substitution value of zeros. So therefore return bigger sum. Time complexity, this can be open to make a pass through all elements to determine sums and whether zeros are there, where n equals sum of all of lengths of arrays. And obviously space complexity, this is going to be O1 to keep track of constant variables.